Guess what time it is? It's time to start. By the way, I'll cut this out of the video. I had went to physical therapy. Today was this introduction. We did some stuff. My back's telling me, what the hell did you do to me? Excuse my language, but it's doing better and I know I'm on the right track. I belong to NCH Medical Group, which is Northwest Community Hospital Group, and they've got a lot of great people. So with that, good morning, everybody. Welcome to another exciting morning of chemistry with your host, me, Dr. White. All right, let's go through some things. First of all, yesterday in my office hour, I found out from a couple of your colleagues that there was a lot of confusion over the chromatography lab, and let me try and clear that up. If you look at the chromatography lab, just try it at home. It's not going to look like the YouTube. Trust me, it won't. But that's just to get a little hands-on experience. The yellow looks like orange because the kit used the cheapest coloring, food coloring I've ever seen in my life, which is probably why they used it. Now, if you look at table 1, where it says dots, and here I might have explained it better, it says use the following for your data, because what you do at home, probably some of the lines won't go straight up. They might go like this even. And that's because you're using filter paper as opposed to true paper chromatography paper. So let's take a look at the following. Everybody see the YouTube on your screen? Thank you. All right, now, this is available in the link. Now, if you scroll down, click on Show More, I also have it in the lab, the first color is red. That means this right up here. The next one here is green. That's what they put on there. The third one right here is blue. And the fourth one right here is yellow. Now this one down here is black. You don't have that in your kit, so you ignore it. Now, see how they nicely put numbers here? Let me do this. All right, now, see how they have these numbers like for red, E122 and E124? That's what I call a dot, this one and this one. So for red, you should all get this right. Whenever you see a number with a letter and number, that's what I call a dot. And even though it doesn't look like a dot, and this with this trail, still we call this one dot. And if you look, I hope you can all count up to 4. You don't have to. And each letter number is considered a dot for that run, like this run, or this color, not run, color. So hopefully that clarified things to help you. Because if you look at the table, look at the YouTube, for the first one, red, you can all should get this right, 2 dots. I'll let you figure out the other blue, green, and yellow. Now, when you have more than 1 dot, it's not pure. I'll say that again in slow motion. When you have more than 1 dot, it's not pure. It's a mixture. That's why you see 2 dots. And if you only see 1 dot, 1 letter number like they have in the video, then it is pure. And hopefully that will allow you to end your confusion. Now, if you're still confused, don't forget, you can always email me And you can always come to my office hours because, as you know, and hopefully you now know it's true, in my class, in my world, there's no such thing as a dumb question. Okay? All right. Let's go through test number 2 answers. I will be cutting this out of the video because I don't want it going. Thank you, Andrew. Uh, aren't you glad they don't have a thumbs down? Actually, I'd like one. But anyways, uh, look out. Even with a bad back, I can still pump out bad humor. But maybe they go together, bad, but never mind. Now I'm just getting silly. But I lost my train of thought. It went Zoom. Oh, I'm going to be cutting this out of the video, even when I lost my train of thought. If you need to see answers again, always feel free to come to my office hours. Now listen carefully. I will not now, and if we were in a classroom, I'd tell you the same thing. I will not entertain questions now, like each person, why did you take off 2 points on problem 18 or whatever? And if you have questions like that, you can either email me, well, actually, you shouldn't email me, come to my office hour, and I'll be more than happy to answer any question on grading. But let's not do it now. And if we were in a classroom, I would be saying the same thing. Now, let me remind you, on test 2, it said right underneath your name, please use proper significant figures for all calculated answers, and please use 3 significant figures for all atomic masses. If you didn't do that in a problem, especially significant figures you got wrong, I took off a point. That's SOP. For those who don't know what SOP is, it's standard operating procedure. In other words, I always do that. So, questions? I guess not. Well, actually, I would have a question right now, and that would be, Dr. White, after 2 tests, what grade am I getting in your class? Well, I assume you've been handing in the labs. If you notice, I've been a real hard grader on labs. Not really. Labs are supposed to be fun, not a way for me to take points away from you. Hold on. You remember that's water, it's a covalent molecule. See, chemistry is everywhere. All right, let's look at how you can determine how you're doing in my class. I haven't done it much. Everybody see my whiteboard? Not yell out. All right, let's look at method A. Let's assume you've taken 2 tests. Look at the 2 tests and take the entire test. And if that's 90 and above, you're getting A, 80, 89 B, 70, 79 C, 60, 69 D, below 60, 59 or less F, because the lowest test is drop. And some of you might be this one. That's method A. Now, another method, I'm going to be real sneaky and call that method B. If you take the sum of your both tests, test 1 and 2, add it up, divide by 2, you'll get a number I'm going to call Y. Why not? It works. Oh, is that awful? But anyways, Y. If Y is 90 and above, you get NA. If it's 80, 89, B, 70, 79, C, 60 to 69, D, below 59, lower, F. And that's two ways. Whichever one of these methods gives the higher grade, go with that. Now, one thing, that's assuming you've been handing in all your labs, which most of you have. One or two of you are a little behind your labs, so make sure you bring it up. And any questions? Have to look at the clock because we're going to go a little longer. Also, I'll put out an email on Thursday. I'm going to start earlier because my physical therapy, the earliest they could get me in, which was Thursday, would be, I think, at 11:30 or 11:45. So I'm going to end class like 11:15 or so. Maybe I'll go to 11:20. So we'll start maybe about a half hour early and get out by 11. And that's only for this Thursday. The rest of the appointments doesn't interfere with our class. I appreciate your understanding. All right. Any questions about anything? I do everything but the meaning of life. I still haven't figured that one out yet. But anything else about chemistry before I move on? Well, in that case, let's get back to gases. Talking about gases, this is for test number 3. And I taught you, let me do a quick check. Everybody see PV equal nRT on the screen? Thank you. I'm going to rename everything. I'm going to say instead of, well, the thumbs up, but also the nodding head people too. All right. Now, I taught you PV equal nRT. And remember, in the winter, oh, that reminds me, I've got to say something. This is real important. Who's ever dreaming of a white Christmas, stop. It's too early to have snow. What was it, yesterday morning? I look out my window about 9 in the morning, and my whole lawn is covered with snow. It's not even Halloween. So who's ever dreaming of a white Christmas, stop, please. I like snow as long as I don't have to drive in it or snow blow my driveway. Then I don't like it that much. All right, remember PV equal nRT is the ideal gas law. P is pressure, and it's always in atmospheres. V is volume, it's always in liters. N is moles, which you know how to do, and temperature is in Kelvin, not Celsius or centigrade, the old name. And R is the universal gas law constant. And for this class and for everything I've ever done, this is the value of R, 0.0821 atmosphere liter per mole K. Now, let me remind you, R is a calculated number, and that's 3 significant figures. So remember, in the winter, when the temperature goes down, these stay constant. This will change, your pressure will go down. In the summer, temperature goes up, pressure in your tires go up. Speaking of tires, let's have some fun with PV equal nRT and the ideal gas law. Well, that is the ideal gas law. All right, let's do a problem. I'm writing this out. Hang in there. All right, it's time for Dr. White to decode my handwriting. Everybody see the problem on the whiteboard? And the first thing I tell you is, oh, look, 15 points. Yes, 15 points. And the question is, your car tire has 8.56 grams of nitrogen at 751 torr and 21 degrees C. What is the volume of the nitrogen in your car tire? Now, what are you being asked to find? Volume. What are you given? 8.56 grams of nitrogen, a pressure, 758 torr, and a temperature, 21 degrees C. Now, we're dealing with a gas, nitrogen, and you see a weight of, you're trying to get a volume, a pressure, and temperature. Notice temperature, pressure, and nothing changes. So immediately you should know PV equal nRT. Now, what are we being asked to solve for? V. Oh, it's not alone. Everybody take a deep breath, relax, take a deep breath, relax, they all relax. We're gonna do some algebra, relax. I'll show you how to do it. So how do you solve for V? You get it alone. Let me remind you, anything divided by itself equals the number 1. So if I divide this side by P, it will cancel out and I'll have V all alone. Whatever you do to one side, you have to do to the other of an equation. Therefore, I now have V equals nRT divided by P. Now, in important information, I'm going to go back to here, you will be given this and this, all this. In the past, I used to make students memorize it. It's almost coming on 2 years, I stopped doing that. Now, notice, pressure has to be in atmospheres, volume in liters, N is moles, temperature, Kelvin, and R is this number. This will be given to you. And the other thing that I will give to you is and that is 760 torr equals 760 millimeters of mercury equal 1 atmosphere. These are all exact numbers because it's a definition. I will also give you Kelvin equals degrees C plus 273. So let's go do our problem because we got a lot of work ahead, which is why it's 15 points. The first thing I have to do is I'll do N. What is N? N is moles. Well, I have 8.56 grams of nitrogen. I want to get to moles of nitrogen. How do I do that? I use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. I'll also put this down in important information. 1 mole of a compound equals its molecular weight. What's the molecular weight in grams of nitrogen. It's the sum of all atomic weights. Nitrogen, if you look at the periodic table, has atomic weight of 14.0. 2 times that is 28.0. Oh, by the way, I forgot to write grams of nitrogen. And now I'll go to my calculator because I'll have 8.56 grams divided by 28.0. Now, this is one of those multi-step that you can round off at each step or wait until the end. I'll calculate both. And I get this number, and I'm going to round it off because I'm going to round off at each step the 3 significant figures, and that would be 0.306 moles. Let me ask. Yep, you were able to see it. Let's go back. All right, quick thing, thumbs up, people. Can you see the problem again? Thank you. And so the number here would be 0.306 moles of nitrogen. All right, so we've got this in the right units. R is given. Let's do temperature. Temperature here is 21.0 or 21 degrees C. It should be in Kelvin. So if we do the math, remember this is addition. This has an exact number. This has only 0 point to pass the decimal, 0 past the decimal. So we've got temperature. Let me go fancy on you. Temperature, R, N, or actually I could do it here. N, R we did because it's a universal gas law constant. And it's left the P, and P has to be in atmospheres. Oh no, it's in torr, which it always will be, or millimeters of mercury. So now we have to do pressure in atmospheres. And we have 758 torr. And if you remember, before test number 2, we did this. We want to get the atmospheres. Whatever we're trying to get to goes on top. Whatever goes underneath, I forgot doing a red, but I hope you'll forgive me. Therefore, atmospheres. And here I'll have torr. And important information, 1 atmosphere equals 760 torr. 1 and 760 are exact numbers. 3, our answer should be 3. So it's time for Dr. White to go to his calculator. Let's do this, 294 for our temperature. And here, plus 758 divided by 760. If I round that off to three significant figures, I would get 0.997. Now, we get back to our fun part. What's N? It's 0.306 moles N2. What's R? At 0.0821. Let me do something. Hang in there. In fact, you know what I'm going to do? Give myself more room. N is 0.306 moles nitrogen. R is 0. This will be given to you, 0.0821 atmospheres, liters, mole, Kelvin. And then temperature, we had right up here, 294 Kelvin. Then this is all divided by my pressure, which in atmospheres was, I forgot to write it down. Hold on one sec. 0.997. Now, guess what? It's time to use your good buddy, your good friend, unit analysis. Let's forget about the pressure on top, and let's just look at the top here. Here we have moles of nitrogen divided by moles, so that cancels out. Here we have Kelvin on top, Kelvin on the bottom, that cancels out. Now, the only thing on top is atmospheres, liters. Here I have atmospheres under here, this divided by that. And the only thing I'm left with is liters. And guess what? That's a volume measurement, so I did it right. So now I'm going to go to my calculator. And let's do it. So what I need to do, and this is something I have to do in 2 steps, this, my moles times the universal gas law constant. Common mistake, some people put 0.821, no, 0.0821 times 294, which is my temperature. And then what I'll do is take this number and divide it by my pressure. And if I come and do, because I know spreadsheets, and if we look here, if I round this one off to 3 significant figures, I'd get 7.40. Here, three significant figures, 7.41, and either one would be the correct answer. And I like doing the round off at each step, but either one of these would be the correct answer. And let's go through this again. We're going to take a break in a couple minutes. I know I went a little longer, but sometimes with this problem, you have to do that. And the key here is, first of all, when you have a gas and you're not changing anything, that's going to be PV equal an RT problem. Can you guys keep a secret? Whenever you see 15 points, PV equal an RT. Oh, I gave something away. Bad, Dr. White. Now, what are you being asked to find? Volume, PV equal nRT. You solve for what you're trying to find, volume, by dividing each side by pressure to get rid of it on this side. You have to on this side. You now have volume equal nRT over P. And an important thing that students mess up, N is moles. You can't put in the weight. You'll get it wrong. You have to convert it from weight to moles, and you've done that for test 2. Don't forget it. Next, temperature has to be not in Celsius, it has to be in Kelvin. And degrees C plus Cal, 273, will get you to Kelvin. Next, pressure has to be in atmospheres. You'll, excuse me, you'll always be given it in either torr or millimeters of mercury. Therefore, you have to convert. We've done this. Use your good buddy, your good friend, unit analysis. You put everything in. I'll give you R, do the math, and that's how you do it. So if you had a tire and it had only 5.5 grams roughly of nitrogen, that's almost 7.5 liters of gas. And that's how you do PV equal nRT. And if I look at the clock, I'm going to give you an extra 2-minute break. Come back at 11:35. We're going to go a little over, but this is a net class, so there's no real start or end time, except when I make it. I try and make it a more VCL. I'll see you at 11:35. With that, I'm going to stretch my back. So get you all back. Let's get going. All right, everybody back? I am. All right, let's do another PV equal nRT problem. All right, let's take a look at the problem. Everybody see that on the screen? 15 points? 15 points, ooh. All right, let's do it. A tank of oxygen gas has 24.5 L is liters oxygen at 851 torr and 22 degrees C. What is the weight, meaning grams, of oxygen in the tank? So what are we being trying to find? Grams of O2. Now, what are we given? Well, we have 24.5 liters of oxygen. The pressure is 851 torr, and the temperature is 22 degrees C. So if we look at all this, we say, you don't have to do that, but I see we're working with a gas. Nothing is changing. The volume, temperature, and pressure are all the same, and we're trying to find weight. Well, guess what? This is PV equal nRT. Remember, 15 points, PV equal nRT. Oh, I gave it away again. But wait, what do I do? For this one, you'll need 2 steps. Step number 1. You use PV equal nRT to solve for N, which is moles. Step number 2, you'll go from moles Dr. White is having a bad writing day. I could blame it on my back. Not really. I'm just having a bad writing day. Moles to grams. And that you learned how to do in test too. So let's do this. I'm going to let you try the first step. I'm going to do a winky dink on you. Everybody help Dr. White do relax the algebra. How do you solve for N for that? You try it. Don't put any numbers. This with the letters, the variables, solve for n. Get it alone on one side. Go. See, Dr. White shares the fun. Don't put any numbers on anything, just solve for n. And when you're done, give me a thumbs up. Or better yet, say a prayer for my back. Or donate to the Save Dr. White's Back Foundation, care of your local post office. All right, I'm not asking you to do any of the other work. We'll do that. Just has everybody solve for n. Just got what n equals to. All right, I'm going to start moving ahead because I want to get you guys out of here before midnight. All right, let's do it. What am I doing? First step, I have to solve for n. How do I do that? I need to get n alone on one side. Oh, it's not. Look what's in the way. It's this right here. How do I get rid of those? Well, if I divide anything by itself, it cancels out. But whatever I do to one side, I have to do to the other side. And t divided by t is 1, r divided by r is 1. So I now have n equal pv over rt. I like to rewrite it, n equal pv over rt. But remember, P has to be in pressure, V in liters. By the way, I'll always give you V in liters like here. R is the universal gas law constant, and T is temperature. That has to be in not Celsius, it has to be in Kelvin. So let's get to work. Let's do P in atmospheres. And we have 851 torr times, remember, I'll give this to you, 760 torr equal 760 millimeters of mercury equal 1 atmosphere. So I'm trying to go from torr to atmosphere. I'll use my good buddy, my good friend, unit analysis. Wherever I'm trying to get to goes on top, wherever I'm trying to get rid of underneath. And where do I get those numbers? Well, first of all, let me draw in the words, write it in. Where do I get it? From 760 torr equal 1 atmosphere. 760 torr, 1 atmosphere. Remember, 760 and 1 are exact numbers. So this is 3. Oh, I'm in my 3 significant figure rut, and my answer should be in 3. Let's go to our spreadsheet. Clear it up. Start up here. And if I round this off to 3 significant figures, it will be 1.12. Yeah. 12. And again, I'll do in column A, round off the end. Column B, I'll round off at each step. So this would be 1.12 atmospheres. So I've got P done. V is already in liters, so I don't have to change it. R is the universal gas law constant, which you'll be given. And then I have T. T in Kelvin equals degrees C plus 273. You'll be given that. 22 degrees C plus 273 equals 295 Kelvin. So now I can come and I'll write it down here. N equals PV over RT. What's my pressure in atmosphere? Common mistake, students put torr in there and they get it wrong. And I was about to do that. And this was 1.12 atmospheres. Volume, which is up here, is 24.5 liters. And I'll always give you a volume in liters. You're doing enough work. You don't have to convert milliliters to liters. And then divided by R, which is 0.0821 atmospheres, liter, mole, Kelvin. And temperature was 295 K. Now, notice right here I have Kelvin divided by Kelvin, so this cancels out. If I look here, atmospheres, that cancels out. Here I have liters, that cancels out. Now, a lot of you aren't familiar with it. 1 over 1 over A equals A. And here I have moles at the very bottom. So this would be 1 over moles. And my units here would be moles. And that's what I want at this step. So I now will put one pen down, pick up the other so I write down the numbers so I don't forget. And we go over our trusty calculator. And let's see, I have my pressure, my volume is 24.5. Universal gas law constant. And then my temperature. I'll do that top first, then I'll do the bottom. Then I'll take this divided by this. Here's the number I get. And if I look at the numbers, and I made a mistake over here, which I told you not to. And if you had done that, and I saw, oh, you put the wrong one in, I'd take a 1 or 2 points. This is definitely a problem. You want to show your work. And if you look at the numbers, either one of these round off the 3 significant figures, you would get 12.2. 12.2. Now, for this one, I'm not going to round off because I'm not done. And this is the number of moles. Am I done? Well, let's go way back up here. We're trying to get the grams of oxygen. Now we have to do step number 2, moles to grams, which you just did for test number 2. So now we'll do step number 2. And here we have 12.2 moles of O2 times something to get to grams of O2. And what do? I use my good buddy, my good friend, unit analysis. And whatever I'm trying to get to goes on top units. Whatever I'm trying to get rid of goes underneath. And where do you get this information? 1 mole compound equals the molecular weight in grams of the compound, the sum of the molecular weights, or I'm ahead of myself, equal molecular weight. The molecular weight is the sum of all atomic weights, and molecular weight, O2, equals 2 oxygen. The atomic weight, the 3 significant figures for oxygen, 16.0, and therefore, do the math, 32.0. And I forgot to put grams of O2 here, moles O2 there. For every 1 mole of oxygen, there's 32.0 grams. And now, remember, 3 significant, 3. Answer should be 3. Time to go to my spreadsheet. If you notice, if I round this off to 3 significant figures, that would be, well, let you do that. Look at 8A, 389.768, round that off to 3 significant figures. Time's up. Keep the 3, keep the 8, keep the 9, use the 7 to round off, that's 5 or higher. Increase the 9 by 1, which gets 10, which increases the 8, so that would be 390. And the other one would be 390. This one I did on the fly, by the way, and this would also, and to really put it in scientific notation, and now we got our 3 significant figures. Now, this one's a little tricky because 390, you'd say, oh, that's only 2 significant. Well, when I do a problem, I calculate it, so this one you won't encounter, but just now I ran the numbers by my head. And let's go through this again. When you're trying to find grams of something, of a gas, and you're given its liters, volume, pressure, and temperature, then you need 2 steps. First step, solve for N, which is moles. Second step, which you know how to do, go moles to grams. And here we solve for N moles by dividing one side by RT and the other. Then remember, you have to put the right units in for PV and R and T. I'll give you R. I'll show you that slide like I did, which units are which. And now we have to convert pressure. Remember, this will be given to you, and this allows you to convert to atmospheres. Temperature, and it needs to be in Kelvin, not Celsius. I don't use the old name there. And it's degrees C plus 273. And therefore, you put the numbers in, you get N as moles, but we're trying to get the grams, and you convert moles to grams, as you see here. Wow, that's a lot of work. That's why it's 15 points. Water break. All right, now, I would like you to do the practice problems because it takes a long time and it's better if you do it. So I'm going to move on. We'll do some more in class, but I would highly recommend, it's going to be on the test number 3, that you know how to use PV equal nRT. I bet that was a no-brainer. You already figured that out.
Dr. White, which chapter are the practice problems on for this particular?
Chapter 11.
Thank you.
You're welcome. All right, let's move on. Now, we did some practice time. I should change this to whiteboard or your monitor. Molar mass. Here's a switch. It's going to be on test number 3 to final. Click. It's off. I still want to cover it briefly. Oop, wrong thing. All right, the ideal gas law and molecular weight of a known gas. One can calculate the molar mass of a gas. You know, what's its molecular weight? We won't do that. Now, let's talk about Dalton's law of partial pressures. And Dalton's law of partial pressures are the total pressure exerted by a mixture of gases, and that's what it should say, is the sum of the partial pressures of each individual gas or the individual gases. Now, what's a partial pressure? I'll never, oh, by the way, click, switches on. And if I could turn it to 10, I've turned it to 15 or 16. You should know this for test 3 and for just in general. Now, partial pressure is the pressure that a gas in a mixture would exert if we're alone under the same conditions. And therefore, the total pressure is the sum of all partial pressures. And notice I say know this. This will be given to you in important information. P total equal P1 times plus P2 plus P3 plus Pn. So if you had 4 and 5, it'd be plus P4 and P5. So let's see how to do this. Huh, come on. All right, let me decode this. And I haven't done it in a while, so I better check. Thumbs up, people. Can you see the problem on partial pressures? 4 to 5 points on your screen? Good. Let's do this. You have a mixture of argon at a partial pressure of 111 torr and nitrogen at 333. What is the total pressure of the mixture? So what are we trying to find? P total. What are we given? P argon, partial pressure, equals 111 torr. P oxygen equals, oh, nitrogen, equals 333 torr. And that's what you have. And notice as soon as you see the name, the word partial pressure, you know that it's Dalton laws of partial pressure, P total, is the sum of all partial pressures, in this case P argon, plus partial pressure nitrogen. And therefore, what's the partial pressure of argon? 113, 111 torr. What's the partial pressure of nitrogen? 333 torr. Add them together. And the answer is the total is 444 torr. And that's how you do it. Oh, let's have you try one. I spelled balloon right. Did I tell you I was always first one down in the spelling bee? All right, let's take a look at this.
Dr. White, we can't able to see the right corner of the paper numbers.
Oh, you don't see anything. Can you see it now? Everybody see it?
No.
Oh, Zoom's being mean to me again. Now can you see it?
Like I see the problem, but I didn't see the numbers on the right hand side.
All right.
Seven,
Now-
5, what is
Now
that?
you can see it. If a balloon contains nitrogen at 751 torr, thank you, Diane. Did I get that right, your name?
Yes.
Look out, I know your voice now. And oxygen at 121 torr, then what is the total pressure of the balloon? Your turn, you can do it. And when you're done, give me a thumbs up or smile or do both. All right, I think everybody's done. Anybody complaining they're not? Nope. So let's do it. Depending on my mood, 4 or 5 points, something like that. All right, let's take a look at this. What are we being asked to find? P total. And P means pressure to total pressure. What are we given? Partial pressure. You have a mixture of gases, and if you see each pressure for each gas, I may not write partial pressure, but partial pressure nitrogen is equal to 751 torr. And then it's got oxygen, and that's 121 torr. And we're being asked to find P total. We know Dalton's law of partial pressure is the sum of all partial pressures of the gases present in whatever we're trying to find. In this case, partial pressure nitrogen, partial pressure oxygen. And if I go over here, and I've already taken the time to figure those out, I can put them in. And if I add that up, hopefully I did that correctly, the total pressure is 872. Remember addition, you get the same number of significant figures past the decimal as the number you're adding up as the fewest. And both of these is 0. Oh, let's do another one. These are fun. All right, let me read it for you. A tank contains neon and oxygen with a total pressure of 888 torr. If the partial pressure in neon is 108 torr, what is the partial pressure of oxygen? Why don't you try this one on your own, then I'll do it. And all of you in your dreams tonight, you'll see me and I'll be saying, you know what time it is? It's time to use your good buddy, your good friend, your analysis. Not for this problem, but I'll be there. Now this one's a little trickier. And when you're done, give me a thumbs up. All right, I think everybody's done. Anybody not done, scream out and say, I need more time. Nope, let's do it. Hold on, I think somebody did scream out. Oh, somebody already got the answer. Let's see if they're right. My turn. All right, let's do it. What are we being asked to find? Partial pressure oxygen. What are we given? P total equals 888 torr, and P neon equals 108 torr. And what do you know? Partial pressure, Dalton's law, partial pressure. The total pressure equals the sum of the partial pressures. Now, how do we get this alone? Oh, wrong one. How do we get this alone? Well, anything that minus anything else equals 0. And that's when you're doing addition, that's how you get rid of one of the variables. So I have P total equals P neon plus P oxygen. I want to get rid of this, so I'm going to subtract. Because this minus this becomes 0, which is left with that. But whatever you do to one side, you have to do to the other. And now I'll rewrite this. You don't have to, but I like to. P oxygen equals P total minus partial pressure neon equals 888 torr, because we took the time to read our problem or write this down, minus for neon partial pressure 108 torr. Do the math, and that would be 780 torr. Remember, this is 0 past the decimal, 0 past, 0 past the decimal. And that's how you do it. Oh my goodness, I went over a minute or two. I apologize. Guess what time it is? It's time for me to say goodbye. Gehen gesund. Have a nice rest of the day. Don't forget, tomorrow night, if you need help, office hours on Zoom. Also, don't forget, on Thursday, we'll be doing the lab. By the way, I noticed I had the wrong title for the lab. Instead of Charles' Law, it'll be Ideal Gas Law. It's a better lab. I changed it. You'll like it much better. And don't forget to hand in the chromatography lab by Thursday. With that, gehen gesund. Bye.